This video is part of the Cybersecurity series of presentations. This presentation provides a deep dive into the topic of denial of service and distributed denial of service that's a common cybersecurity attack that's widely used. Denial of service is a type of network attack. That means it's typically launched over the internet. And it's aimed at servers, and typically it is aimed at web servers because web servers tend to be the front end or the world-facing interface for a company where a lot of the e-commerce occurs. Keep in mind, like all web servers or computers, web servers also have limited resources. That means they have fixed amount of CPU or CPU time, they have fixed amount of memory or RAM, and they have fixed amount of network resources like connections and such. Since they have upper limit on these resources, a server can only process a given number of requests per second. So if there are more connections or more requests that are received by the server, those requests will take a longer time, or sometimes those requests can even be dropped. This is normal operations of a server. That means anytime the server has a lot more work to do, some of the work will be slower and some of the work will be dropped. This is just normal way the servers work. Denial of service essentially leverages or takes into account this fact that servers have limited resources and drop connections, and they focus on trying to generate so many requests to overwhelm the capabilities of a server. So an attacker basically makes a large number of requests to the same server, and these large number of requests overwhelm the server's capabilities and cause the server to drop or deny requests from legitimate users. Let's look at it from a picture perspective. Typically, you'll have servers that are operating under nominal conditions or nominal load, and they'll tend to respond quickly and efficiently for requests from different clients. This would normally be the way systems are designed, and this is the way we expect it to work. However, a malicious user or an attacker starts sending a large number of requests or a large number of network packets to the servers, thereby overloading their CPU, network, and RAM. And this causes the server to drop some of the packets. Of course, it drops some of the network attackers' packets too. But what happens is a large fraction of the packets get dropped, and legitimate clients who are trying to access their website will no longer be able to efficiently utilize its resources, thereby impacting the service provided by the web server. Let's look at an example code that we could use to launch a DDoS attack. Here we'll use multiple threads. So here is the main method. That means this method is going to run from multiple threads, and it's going to attack a given host, let's say www.bad.com, at a given port. Typically it'll be port 80 for a web server, but you could use different ports to attack different types of servers on the internet. This method is going to loop forever. Basically, it's going to do something simple. It's going to create a connection to the given host at the given port, and it's going to sleep for 5 seconds, just holding up the connection, not doing any interaction. So hopefully that the TCP timeout will not kick in, and it'll hold the connection for 5 seconds. Now in our main method, we're going to spin up a bunch of threads to call the thread main method. But before we do that, we'll check the command line arguments. So you will use the first command line argument with the host name, the second one the port number, and the third parameter will be the number of threads we want to use. So we'll pull that data out for convenience, and then we will spin up the threads based on the number of threads specified. This code will spin up a lot of threads, and each thread will concurrently make connections to the server. In this case, if we have 100 threads, we will simultaneously make 100 connections to the server, trying to overwhelm the resources. Here, instead of 100, you could use 1,000 threads if you want to do a lot more damage on the server. And of course, we wait for the threads to finish. In this example, the threads never finish because they constantly run, trying to create and dropping connections to the server, trying to keep the server busy processing these malicious requests. And this is an example of how you could launch a denial of service attack. Many servers protect themselves from denial of service because it's a very common type of attack that can be easily launched. So a lot of servers protect against those type of an attack. Typically, servers will limit the number of connections a single user can do. Sometimes the servers will temporarily blacklist IP addresses that generate a lot of traffic or invalid logins to protect themselves. And typically, most organizations will have multiple independent servers to handle the load. So, what adversaries typically do is they try to subvert or work around these by doing what's known as a distributed denial of service attack or DDoS attack, where they use many clients with different IP addresses on the internet to attack the single server. Usually, this attack, the DDoS attack, is launched from a set of compromised machines that have been previously compromised using a Trojan or malware. And these set of compromised machines collectively work together to attack a given server. And this compromised set of machines is often called a botnet. Or you can launch these attacks from different cloud services, as it's easy enough to spin up many virtual machines on a cloud. So in a distributed denial of service, notice that there are many attackers sending many packets. So here the server, it's difficult to see which packet is coming from a legitimate user, which packet is coming from an attacker. So the server has to process all of these packets to figure out what's going on, and this overloads or overwhelms the servers, thereby denying service from legitimate clients. These many attackers are typically called a botnet, and botnet is nothing but a set of computers that have been previously compromised to do these kinds of distributed DDoS attack via malware or etc. So this botnet is built that way, and then they launch a distributed denial of service. There have been cases where a botnet with more than 380,000 mobile devices has been used to launch a DDoS attack. So some of these DDoS attacks can be pretty massive across the internet on an organization. Let's think about why you would do this kind of a DOS attack. Adversaries have different motivations to launch DOS or DDoS attacks against a given server. One common use case actually is a legitimate use case is to do vulnerability or penetration testing. This is where you stress test a web server or a server system to try to ensure to see if it is robust against a DDoS attack. So there's actually a valid vulnerability testing that people do. There are economic motivations, so you can launch a DDoS attack against a competitor so their website is slow, and since their website is slow, maybe the e-commerce that happens on their website will be reduced. Sometimes gamers will launch DDoS attacks against each other because the online gaming system, the few milliseconds of response times can sometimes add up to make a big difference in the overall gaming performance. Of course, there are political or ideological motivations where state actors can launch DDoS against other state actors or other countries. And of course, this gets into the realm of cyber warfare as well. Now that we know a little bit about DOS and DDoS, let's think about how to mitigate or protect infrastructure against these kinds of attacks. The challenge with DDoS attacks is it's hard to distinguish immediately between legitimate traffic versus attack traffic. So most of the time servers have to process some level of data in order to detect and try to protect themselves against these types of attacks. So imagine that in a country you're a server with clients connecting from different places trying to get service from you. It is when the packets come, it is not easy to tell whether it's coming from a legitimate client or coming from a botnet that has been actually subverted to launch a DDoS attack against the server. So one of the first steps that are done to mitigate against the DOS attack is to use a firewall that can do what's known as stateful inspection. So it can look at packets coming from different connections, and based on the rate of these packets and traffic patterns, it can start protecting or dropping packets that it thinks that it's coming from malicious users. There are lots of companies like Cisco and such that provide appliances that you can utilize on your network to try and mitigate some of these DDoS attacks. The next strategy is, of course, to have multiple servers to try and balance the load. Each one of these servers can have different IP addresses. So for the attacker, it's not just one attack surface. The attack surface is now much bigger and wider, so they would have to put in more effort to attack the infrastructure. And of course, the firewall on top of that helps a little bit to also mitigate some of the malicious packets coming in. And keep in mind, with modern cloud computing infrastructures, multiple servers can be spun up on demand. So when the traffic patterns suddenly increase, you can scale up to try and handle the traffic. The next strategy that a lot of companies use is to do geographically distributed servers. So here you're trying to reduce the congestion in the core by moving the servers to different geographic locations. So again, here cloud computing service providers that have data centers in different locations that are geographically distributed can help with this kind of an infrastructure and coordinating the different servers using a content delivery network or CDN. So these servers are interconnected with the CDN, and then they manage the traffic in their local geographic areas. So attacks in one area will not completely subvert the servers or overwhelm servers in other geographic areas. The next strategy for mitigating DOS attacks is to push the packet filtering closer to the source of the attack. This decreases the number of malicious packets flowing on the network and coming all the way to the server, and reduces network congestion and other issues in the network. Of course, this requires collaboration with the Internet Service Provider (ISPs) to move the packet rejection closer to the source of attack. Since this requires collaboration with multiple companies, this is feasible only if you're a large company to move the rejection closer to the source of the attack. And of course, government can also play a role here to help move and work with ISPs to move the rejection of packets closer to the source of attack. And this is one of the most effective ways of mitigating a DOS or a DDoS attack. In summary, denial of service is a network attack. The objective here is to overwhelm servers, thereby hindering effective use and denying service to legitimate users. In a distributed denial of service attack or DDoS attack, it uses many computers, and typically these computers have been compromised earlier through other cybersecurity measures or to other cyber weapons, and this collection of computers is often called a botnet. There are several motivations to do a DDoS attack. It could be for testing, for economics, or to subvert a competitor. It could be based on ideology or as part of cyber war. And mitigating DDoS requires several different strategies, so you have to have a plan for this. Using firewalls and load balancers with multiple servers helps. Using a geographically distributed infrastructure via different cloud providers and a content delivery network will help with this situation. And of course, pushing the filtering closer to the source of attack also helps to mitigate some of these issues.